Okay, Assalamu alaikum guys. Today, as promised, to cover every single thing that we have done in class. So we're gonna talk about work. And as you know, work and energy, they both are expressed in joules. So you guessed it, work and energy are just two faces or two forms of the same thing. Work is expressed in joules, and work is very easy to calculate. Let's imagine one of my students here is pulling a box with a force of 100 Newton over a displacement that you want to call, depending on your preference, delta x or s or d, whichever you want. And as you could see here, the 100 Newton are parallel. The force is completely parallel to the displacement, and that is the best scenario when you want to pull a box. So this is the maximum work that you will get. So work here is just going to be the force times that displacement. So in this example here, we're gonna take delta x or s or d, whatever you want to call it, as 3 meters. So it's going to be 100 Newton times 3, it's going to be 300 joules. Remember that the force needs to be expressed in newtons and that the displacement needs to be expressed in meters. If it is expressed in some other unit, you need to convert it to the SI unit, which is meters. Okay, now if you want to displace your object in this direction, so this is your displacement, but instead you apply a force like this, you know, so you're pushing on the box like this. So you see that the force here forms an angle of 90 degrees with the displacement. Do you think that this force is working? This force is definitely not working. So when the force is perpendicular, so if you apply a force like this, okay, this force, you apply it like this, this force is not going to be working, will have a zero work, because it's not going to produce any work. It's not going to be able to pull the object in this direction. So when the force is perpendicular to a displacement, the work resulting from that is just zero. Okay, so, and that is of crucial importance. The work of a force that is perpendicular to delta x to the displacement is just zero. It's zero. Okay, so now let's imagine that the surface that you're pulling your object on is not smooth. Okay, let's imagine that it is a rough surface. So whenever we say a rough surface, it means that there is some resistance. Okay, so this is, and let's imagine that the magnitude of the force of the resistance is 20 Newton. So guys, tell me, do you think that this force is going to be helping in pulling the object along this displacement? Is it going to be helping? No, definitely not. So this force here is going to produce what we call a resistive work. It will produce a resistive work. That work is going to be what? Is going to be negative. So let's calculate the net work here. So work net of all these forces. So the black force here, F, okay, is going to have F times D, and then the green force here is going to have a zero work, and then the red force here is going to be the magnitude, which is 20. Okay, I'm just going to write it as FF times D like this. So the net work here is going to be 100 times 3 plus the 0 because that's perpendicular to the displacement, and then minus 20 times 3. So 100 times 3 is 300, plus 0 is 300, and then minus 20 times 3, that's 60. So this is going to give me a 240. I'm just in a quandary to which pen I should choose. Okay, 240 joules. Okay, you got it? So when the force is parallel to the displacement, it produces the maximum work. When a force is perpendicular to the displacement, it produces a work equal to 0. And then when the force is anti-parallel, or making, you know, the displacement is to the right and the force is to the left, that force will produce or will result in a resistive work that is negative. I hope that this is really clear. It's super duper easy. And then I'm gonna generalize it to just a force making at an angle of theta with the displacement. And since I know that you just had your test on trigonometry, there is no reason that you're gonna tell me, oh, we don't know that. Okay, so this is our box. This is our displacement, you know, this is our displacement, delta x or s or d. And then the force here, that 100 Newton force, is at an angle, and the angle, this opening, we like to use the Greek letter theta for it. Okay, so, okay, some trigonometry, theta, and then cosine theta. When theta equals 0, what does it mean when theta equals 0? When theta equals 0, so this is my force, it is parallel to the displacement, and cosine theta equals 1, and the work is just going to be F times D. When theta equals 90 degrees, okay, so I'm either applying a force like that or a force like that. So this is the theta here, 90 degrees, okay, 90 degrees like this or like that. Cosine 90 degrees is 0. Otherwise, you would have gotten a 0 on your test with Mr. Brian, okay? And the work is also 0. And then when the force is resistive, you know, so it means it's like this. What is this angle here? What's this angle? This is from here to here, this is what? This is 180 degrees or pi radians. So the angle is, okay, pi in radians or 180 degrees. I think I'm craving some pi. Okay, and so the cosine is -1, and the work is going to be is going to be negative. You see how work can be positive, it can be 0, and it could be negative. Work is a scalar, okay? Work is a scalar. Okay, and therefore you could deduce, or you could find out, or you could remember the formula that we have seen is that work equals actually F d cosine theta. Okay, F d cosine theta. That's it, you know, that's all I want you to know about work. I'm just gonna touch on power, and you've got the power. Okay, so what is power? What is power? Power is a rate of energy or rate of work, you know, like whenever you ask someone to perform a task or to do some job at your house, and then you ask them, how much do you charge? And then they tell you, I don't know, $20 an hour, or $100 an hour, 100 dirhams an hour. So something per hour, that is a rate. And half of physics is about rates, okay? So power is a rate of energy, so it is just energy per time, or work per time. So, and then let's say the student who was performing 300 joules, you know, he was applying a force of 100 Newton and the displacement D was 3 meters. And let's say he was doing that in 3 seconds, just to simplify my life. What is the power, or what is the rate, the rate of change, or the rate of energy per time? That is your power. So power is just going to be the work. Energy, work is the same thing. So 300 joules, the 100 times 3, divided by time, and the time, you guys, needs to be in seconds, and then it is 100. And what is the unit? It's joules per second, but we are going to name it watts. So this is it. So what's the power? What's your name? Okay, so that's P for you guys. And you've got the power. Get that 888 on your exams. Okay, bye.